Welcome to my YouTube channel and the website Global Math Institute. In this video, we will learn how do we model the product of polynomials. Hi Rohan, how are you doing?
I'm good, sir. How are you?
Very good, very good. So Rohan, today we will do quadratic equations. We will see how do we multiply polynomials.
Okay, sir.
Have you done that before? I think you have in grade 9.
I have last year in grade 9, I have done it, but when looking in the textbook, it seems that there's also the diagram, so I wonder how you do that.
Yeah, the model. So model of these product of binomials, we'll understand those today. Let me just take a whiteboard to begin with. Okay, so can you see my whiteboard?
I can see.
Okay, very good. So, so you know what this is. I'll just write down an equation and you help me expanding it, right? So if I write 2 times x plus 3, then what is the result?
So it's a 2 times x plus 3, right, sir?
Yeah.
So that would be 2x plus 6.
2x plus 6. So you applied the distributive property, right?
Yes, sir. So I'm multiplying both the x and the 3 in within brackets.
Correct. So when we make a model, we could do something like this. We'll represent one x like this bar, 1x. This is my x. Or you can say a straight.
So basically, it's like that ones, tens, and hundreds and
1
thousands. So it's like models like this cube, a rectangle, and then like a big cube and all that.
Yes, yes, yes. And then one small thing will just represent as 1 unit. Is it okay?
Okay, sir.
So if I have to represent x plus 3, I could say something like this also. This is my x. I'll just draw a line. Is it okay? Or let me make one. X, and that one thing is plus 1, plus 2, and plus 3. So I've just made these 3 things. Is that okay?
Okay, sir.
So let me just give it a width just to show you that this is clearly visible. Okay. So that is x plus 3. Right? So I can write this as x plus 3. Is that okay? Now if I have to multiply it by 2, it means what? So it means that I'm going to multiply this by 2. So I'll have 1 unit here and 1 unit here. So these are my 2 units by which I'm going to multiply this. Correct?
Okay, sir. So basically, the one that's going vertically down, that represents the multiplication, the multiple.
Yeah, let me write this. When I have 2 of them, then in that case, what really happens is that what we get here, let me show it in a different color. So we have, when we multiply this, I have one block here, and this. These units. So in blue, we get their product. You see how many are there? We have got 2 x's and 6 units.
Okay, sir. So basically, it's like a T, right, sir? So the top, like the sides are your outside of the brackets. The one at the top is your original equation, and then at the bottom, where the blue is, that is your answer, right, sir?
Correct. So we could also do it in a rectangular form. And let me just show you the rectangular form here. So where I can make a rectangle here. And I can say, well, this is my x. Let me show it equal. Okay, let me just do it, read it. In a rectangular model, I could do like this. So in this particular case, one side of the rectangle is x plus, these are my 3 units, correct?
Yes, sir.
And the other side is 2 units. 1 plus 1. Is it okay?
Okay, sir.
So what we get here is, these are my 2 x's and these are my 6 units. So I could write this as 2x plus
6.
Is this clear to you?
Okay, sir. So in this one, what happens is that you make it into a big rectangle and you split it up as the answers and how
Yeah.
much wide it is. So
Yeah.
it's basically similar to the first one, but you're not separating it, right, sir? It's all
Yeah, it is
connected.
easier to sketch. It is easier to sketch. Is that clear to you?
Yes, sir.
So we will actually use this rectangular model rather than making those big rectangles and squares. Kind of difficult to for me to draw here. So we'll use this rectangular model to expand. So here
Okay,
what we
sir.
have done is we have multiplied monomial with a binomial. Is it okay? Binomial is two terms, monomial
Two.
is one term, right?
Okay, sir.
Okay, let's erase it and then do some more examples. So if I have to do, for example, if I have to do 2x times x plus 3 now, instead of 2 times, I'm just doing 2x times. So what will that mean? Can you make a model for this now?
Okay,
So
so
we could have a side. Yeah, you make and I'll also make here. X
okay, sir.
by plus 3. And this is 2x. So what do you get? You get something similar to what I've drawn?
Um, I'm not sure how to draw it like that, sir. So I did my best at drawing it like the other ones, the block versions, because
I
I was confused on how to draw it as that. But I got like x squared, and then like x, and then I got six x's and two x squared.
6x. Yeah, yeah, 6x. You're
It's
right.
just I didn't know how to draw that one because I only remember like the just the cube and the rectangle. That's it,
Correct.
not the big square.
Correct. So we finally got 2x squared plus 6x. And do you see this model now? How we have drawn and how we could get the result?
Yes, sir.
Okay, let's do one more.
So basically, sir, the cube is worth one. The rectangle is x,
Yeah,
and the square is x squared.
correct. So we will now use length. Let's say this length is of length x units, right? And this as 1 unit. Is it okay? So if
Okay,
I have
sir.
x plus 3, so basically what I want to do is I'll go here and say, well, this is my x and these are my 3 units. Is that clear to you? So on one side, I have, let me write x plus 3. Is that okay?
Yes, sir.
Now on the other side, I have x plus 2. So I'm making this as my x units equal to this, correct? And then 2 units. So 1 and 1, 2. Do you see that? And now I'm going to complete my rectangle.
Okay, sir.
Join the other lines like a matrix, rows and columns. Do you see how I'm sketching now?
Yes, sir.
So on this side, I have x plus 2. So if you look into this as an area, of rectangle, look at it as an area of rectangle. So you get what? This area is x times x, right? These two sides are equal. The area is x.
So x squared.
These are x units. These are all x units.
Okay.
And these are 1 square, correct? So 1, 1, 1, 1, 1. Do you see this? So now when you do that, you get your result, which is equal to x squared plus 1, 2, 3, 4, 5x plus 1, 2, 3, 4, 5, 6.
Okay, so what you did was you drew a big square and then you wrote down each of the sides and then calculated how much it is to get your total, right, sir?
Correct. And now let's look into distributive property. If I multiply by x, then I get x squared plus 3x. And now if I multiply by 2, I get 2x plus
2x plus 6.
And when you combine these terms, you get x squared plus 5x,
plus x.
which is same. Do you see that? So,
Yes, sir.
So in this particular figure, what you notice is how do we multiply by binomials?
Okay, sir. So when doing it, the second equation has to go on the top and the first equation has to be on the side, right, sir?
Not necessarily. You could interchange. So if I change the orientation, the area remains the same. You see that? So important. Area is constant. Is that okay?
Okay, sir.
So it doesn't make difference. So whether you put x plus 3 on top side, length or width, it doesn't matter. Is it clear to you?
Yes, sir.
Got it. So that is how we are going to multiply binomials. Now, we could also use signs. So that means we could do like with product signs, you understand? If you had, let me take another example, let me clear the screen. Now we will do x plus 2 times x minus 1, let us say. Now, how do we do minus 1 with the area? So, one way is we can use a different color for minus. Is that okay?
Okay,
So,
sir.
let us say our green color is positive. So, we are using green as, or let me use red and blue, right? So, let's use red as, let's say, positive, and let's say blue as negative. Is it clear? So
Yes,
when
sir.
it is read as positive, x minus 3, 1 means x is this 1 unit of x. And then I'm making with blue minus 1. So this blue is minus 1 for me. Is that clear to you?
Yes,
So
sir.
this basically represents x minus
1.
So x plus 2 will really mean that I have 1x. This is the same length as this, correct? And then 2 units, which is same as that blue unit, but they are positive, and therefore I'll keep them red. You see that x plus 2, right? So here I have x plus 2, and on the other side, I have x minus 1. Okay, now I will complete the square now. Yeah, let me use a neutral color to complete the square. Okay. Now, what do you notice? So in the units which have both red, both same colors, same color means positive, right?
Yes, sir.
These are also same colors, since this is let me because this was all red, right?
Yes, sir.
But on other side, this line was red, but from the other side, it was a blue line. So if you look into this area, that remains blue, right?
Yes, sir.
Minus 1. So basically, what you get here is x, these are positive, and that becomes minus 2 as this has become negative x. Sorry, let me write it differently. Because here I'm multiplying x with minus 1.
Yes, sir. And then you
That will
have
be negative x. And these two units are negative 1, correct?
yeah.
So if you combine these, what do you get? You get
You
x
get
squared
x
plus x, that is 2x, minus x,
so
minus 1,
x
minus 1. So you can write this as x squared plus x
minus 2.
Is this kind of clear to you?
Yes, sir. I understand it. It's just that for the diagram, sir, so when doing it,
Okay.
like especially with negative numbers, sir, like negatives, you have to draw it as like before it's simplified, before
Yeah.
simplified version.
Yeah.
Okay, so it's not like the normal positive ones where you can just draw it as simplified.
Correct. So negative because some will cancel.
Okay, sir.
Some will cancel. So if you look into distributive property, so you can see that, we have here x squared minus x. And if I do with the other, which is 2, we have plus 2x minus 2. So when you combine these terms, you get x squared plus x minus 2.
Minus 2.
So you get the same result.
Because
Right?
when I was drawing it, sir, I was drawing x squared plus x minus 2. That's why. But I was confused on how come I had extra space.
Yeah. So we'll do this once again. Is it okay?
Okay, sir.
Let me clear this. So this time, let me write this as x minus 2 times x, let's say plus 1. Let's keep it simple this time. One man negative, one positive. So as I was saying, I'll put red as positive. So this is x. And then I got minus 2. So let me write minus 1 and minus 1. These are my minus 2. So here I have x minus 2. Is it clear?
Yes, sir.
Now I want to do x plus 1. So if I'm doing x plus 1, x side will be positive, correct? And 1 is also positive. Is it okay?
Yes, sir.
So I got this x plus 1. Now, let's try to multiply this and this. So when I multiply this and this, we have same sign, so that becomes x squared, correct?
Yes, sir. And then the bottom is just x.
The bottom is just x, correct? On the other hand, if I multiply this x with these two negatives, I get negative.
Negatives.
Negative, correct?
Yes, sir.
With these negatives on this side positive, I'm getting negatives only, correct?
And then on the bottom, you just get two negative ones.
Yeah, so this is negative 1, this is negative 1, this is negative
X.
and another negative x. Now is it clear? Much better than before, correct?
Yes, sir. It's easier because now I was able to understand how to actually draw it.
Yeah, so what we get here is x squared, 1 plus x, and then we have minus 2x, and we have minus 2. So I could now write this as x squared minus x minus 2. Perfect?
And basically, sir, from the diagram, right? So you can also predict like what the answer of the equation is, right, sir, by looking at it as well.
Yes. So now
So
let
if
me
I
use the distributive property just to show x squared plus x. When I multiply with minus 2, I get minus 2x minus 2. Is it okay?
minus
When I combine them, I get x squared minus x.
minus x.
So this is even better, right? So slowly we learn. Let's take the last example on this type of thing. And this time I'll take both negatives. So I'll better write in x minus 2 times x minus 3. So
X
draw this
minus x minus 3.
x. So that is my x minus 3, and this is my x minus 2. Okay. So I'm going to now combine. So when I have two sides as positive, clearly this is x squared. So let me just draw a neutral color here so that we have our rectangle. We'll color it later. Now let's decide what should we shade this as, blue or red. Is it okay?
Okay, sir.
So that may be another approach. So we have now positive with negative. So it will be negative, right? Since this side is positive, right?
Yes, sir.
And now if I do positive with positive, so these are positive sides, plus, and these are negative sides. So this is negative x, negative.
And negative x.
On this side, we have two negatives, correct?
Yeah, so it'll be just 1, 2, 3, 4, 5, 6. So, sir, would it be like this? How I drew it?
You are right. So it is easy. So we can actually make the squares if you are using one color and write negative and positive as shown in this particular case. Is that clear to you?
Yes, sir.
So clearly we get x squared as one positive, right? And then we have these two negatives are all positive here. So we have minus 5x
Plus 6.
plus 6, right? And you
Yes.
can actually do it here also. X squared minus 3x, and then with 2 minus 2 minus 2x plus 6. So we get x squared minus 3x plus 2x. I should write this as minus 5x, correct? Here?
Yes.
Good job. So now let's do perfect squares and see how perfect squares can do. Which I'm trying to say is something like this. If I have x plus 2 whole square, how will I expand this?
X plus 2 whole square, sir?
Yes.
So it'll be x squared plus 4.
So we have this side as x, 1 and 2, right? And here also we have x, 1 and 2, correct? So if I make this rectangle, joining my lines, I get this figure, correct? Which I could write as x squared, x, and so I get x squared plus 4x plus 4, correct?
Okay, so x squared plus 4x plus
Which
4.
is same as x plus 2 times x plus 2. So the sides I have taken as x plus 2 and x plus 2. Is it clear to you?
Okay, sir.
And when I expand this, first with the x, I get x squared plus 2x. And then with 2, I get 2x plus 4, correct? So we get
Yes, sir.
x squared plus 4x plus 4, correct?
So, sir, in these equations, like, are you able to, what do you call, expand the equation? Like, if there's like a square root, like, for an example, 2 or 3, right, sir? You can just expand the equation and all that.
Yeah, we are doing expansion of equations. So we are basically doing expansion of equations. Is that okay?
Okay, sir.
So it is expand equations. Perfect. Now let's take general equation. Now I have an equation which says a plus b times c plus d. How will you show this?
A plus B multiplied by C plus D, sir?
Yeah.
So A C plus AD plus BC plus BD.
So let me show you. A plus B could be one side. Let's say this is A plus B. And C plus D could be the other side. Let's say C plus D. Correct?
Yes, sir.
Now if I multiply, what is A times C equals to? AC.
AC,
What is B times C equals to?
BC,
What is A times D equals to?
AD,
And what is B times D equals to?
BD.
And therefore, what we really get is AC plus AD plus BC plus BD.
BD. Yes, sir.
So that is what the expansion is. When you multiply first with A, for example, you get AC plus AD, and then with B, you get BC plus BD. Is that clear to you?
Yes, sir.
Correct. So that is how we could actually resolve, or rather model, product binomials. Is that clear to you?
Yes, sir.
So I think that was a simple model to see how do we represent the product, and also we also found perfect squares in this particular fashion. Clear?
Yes, sir.
Now, if you have to do, here's a test question for you. Let me clear this. If I
You
have to
can
do
now
A
write
plus
down the
B plus
solution of the
C
test
whole
question,
square,
and in case there is any
A
difficulty,
plus B
feel
plus C
free
whole
to send an
square,
email to me.
what is going to be the
Thanks for
answer
your
for this?
time
Can you tell me?
and all the best.